Now let's level up in our presentation. Okay, you have seen some 5 practices before that. So now let's look at question 6, but now this time we're going to write it out properly. Okay, zinc element on its own, so this is oxidation state 0. Copper oxidation state plus 2, cause simple ion. Zinc 2 plus, simple ion, so it's a plus 2. Copper is an element on its own, so it's a 0, there's no charge there. So now, you can see that zinc changed from a 0 to a plus 2. So how do I write it? So you can say that, right, this is how you're going to write answers. Oxidation state of zinc, okay, in this case here is an increase from 0 to plus 2. Therefore, oxidation occurred. Okay, next one, we can say that oxidation state of copper decrease from plus 2 to 0. Therefore, reduction occurred. So in this case, is it a redox? So how do I express the last sentence? Since oxidation and reduction occurred, comma, this is a redox reaction. So you realize, how do I prove whether it's a redox reaction? I try to show that oxidation occurred. Next, I show that reduction occurred. Then I will say that both of them occurred, therefore it is a redox reaction. So this is how you go about in terms of the explanation. Okay, now let's move on to the next question. NH4Cl gives you NH3 plus HCl. Okay, now we're gonna level it up. Now let's speed it up. I'm gonna tell you this. Okay, all the elements in the compound, they will actually follow the periodic table, the valency in the periodic table. For metals, it will be a positive. For non-metals, it's a negative. So in this case, so let's take a look at the periodic table. In actual fact, when talking about oxidation state, just remember this. Okay, now let's draw a simple line to show where is the metals and non-metals. Okay, now things from group 1 to group 3, generally they'll follow oxidation state of plus 1 for group 1, plus 2 for group 2, plus 3 for group 3. Now for group 4, generally it can be a plus 4, okay, or minus 4. So you must look at the question, but most of the time it will follow a plus 4, so just take note. Okay, so 1, 2, 3, 4, and then for group 5 it will be a minus 3. And let me use a different color, minus 3. Group 6 it will be a minus 2. Group 7, minus 1. So you can see that if the element is in a compound, okay, element is a compound, generally group 1, group 2, group 3 will be a positive positive oxidation state. How positive it is, group 1 is obviously plus 1. Group 2, plus 2. Group 3, plus 3. For the non-metals, okay, for group 5, group 6, group 7, it will follow a minus 3, minus 2, minus 1 because they belong to the non-metal side. The only special one is in group 4. Generally, it can be a plus 4 or minus 4. However, most of the time, it will take on the role of a plus 4. So this is actually most of the time that is happening for your group 4 elements. So now let's go back to our question. NH4Cl, NH3HCl. So nitrogen, okay, because it's an element of compound, it will follow the valency. Okay, you have an oxidation state. So nitrogen, group 5, so oxidation state minus 3. So this guy here, minus 3. Hydrogen, this fella here is a bit special. He's in the middle here. But most of the time, it will follow an oxidation state of plus 1. Okay, remember, hydrogen generally always be a plus 1. So hydrogen here, element in a compound. So the hydrogen is a plus 1. Chlorine, okay, is a element in the compound, so oxidation state -1. Same thing, this one will be a -3, hydrogen +1. Because these are elements in a compound, hydrogen in a compound again, so it's a +1. Chlorine in a compound, so this is a -1. Okay, so in this case here you realize, hey, none of them change. So how do I write the answer? What you write is, since there is no change, there's no change of oxidation state for the elements, comma, therefore this is not a redox reaction. Okay, quite simple, isn't it? Okay, now let's look for the next one. Sulfur. Sulfur, element on its own, so oxidation state 0. Oxygen, oxidation state, also 0 because element on its own. Now, this one is a little bit tricky because, you see, if I ask you to follow the method which I said just now, you realize sulfur, oxidation state, -2. Oxygen, oxidation state also -2. If two of them are -2, how can the overall charge be a 0? It doesn't make sense. Okay, so what I'm going to follow is the general rule, which is that oxygen most of the time is definitely -2. Okay, so we're going to erase this. So now let's determine the oxidation state of sulfur. So we know that SO2, okay, oxygen is a -2, but how many of them do they have? We have 2 of them. We say that sulfur maybe is a X, we do not know the charge. So X plus 2 minus 2 is equals to 0. And we will realize that X is equals to a +4. So in this case, my sulfur is a +4. So I'm going to write out the sentence here. So take a look. How is it going to be written out as? We will say that oxidation state of S increase from 0 to +4. Therefore, oxidation occurred. Okay, next up we say that oxidation state of O decrease from 0 to -2. Therefore, reduction occurred. So with these two statements, you can say, therefore, this is a redox reaction. Okay, so you can see how I'm writing my answers here. Now, let's look at the last one. Hydrogen in a compound, this is a +1. Chlorine in a compound, this is -1. Okay, sodium +1, oxygen -2, hydrogen +1. So, okay, everything seems alright so far. Sodium, overall charge +1. Chlorine -1. Hydrogen, okay, +1. Oxygen -2. Okay, so you can see all these numbers here. Now, let's take a look at the hydrogens. Hydrogen from +1, both at the start also +1. In the end up, both also become, hydrogen remains as a +1. So therefore, hydrogen, no redox, no oxidation, no reduction. Chlorine, from a -1, it remains as a -1. So no change at all again. How about sodium? Initially +1, after that still +1. So no change too. Oxygen from -2, it remains as a -2. So therefore no change. So is this a redox? Answer is no, not a redox. Okay, so that's the end for the practice question.